Thank you. Here we have Elena Lowery from IBM, and she's here with us to talk about Watson X and MongoDB. We're going to learn how to scale the impact of generative AI with trusted data and governance. When we're going to have an end-to-end demo. So with that, take it away, Elena. Thank you so much for being here.
All right. Well, thank you, everybody. Actually, I was going to name this session something to do before the reception, but our product management disagreed. And we have to go with this title, and I actually do have to show you a little bit of our product, Watson X, and how we can use it with MongoDB. Now, I know you had quite a bit of education in this session already, and so I thought maybe we'll play a little association game where you get to showcase your knowledge. It's unfortunate it's too loud here. I can't hear your answers, but think about it. So, if generative AI is a car, then a large language model is that black box in the middle. Nobody knows what it does, right? But actually, what it is the engine, right? It's what makes generative AI works. And if we were to continue with that analogy, then a prompt is what? A gas pedal, right? It's what the instructions that we give to a large language model so that it can perform a specific task. I also like to describe it, the prompt, as a conversation between parents and a teenager, where a parent provides very detailed instructions and the teenager completely ignores it and does whatever they want. So that was a little overview of generative AI. And what I want to discuss next is projects. Do we have anybody here who likes to work on do-it-yourself projects? Do we have any DIY enthusiasts? And summer's coming up, so we're all going to be heading to Lowe's and Home Depot. Just want to tell you a personal story. I recently bought a bed frame from IKEA, and they sent me a tree trunk and a saw. So I will be busy with some DIY projects, but that's in my free time. That's on the weekends. What I do for my day job is I work on AI projects. I help our clients build AI-driven applications. And through my work with the clients, I have identified 3 factors that are critical to success of implementing AI-driven applications. And this is what I want to talk to you about for the next 25 minutes or so. So the first thing that we need is clearly identified use cases. And if you are a frequent user of ChatGPT, if you use generative AI, you may be looking at this list and thinking, well, that's not how I use generative AI. I usually use it to come up with a grocery list or with vacation ideas. But if you are an AI engineer and if you have been trying to build AI applications, I hope you agree with me that these are use cases that we are considering. So number 1, conversational AI. This is intelligent chatbots that are able to understand our questions in natural language and respond with very impressive results. We have content generation use cases, generating abstracts for this conference, generating marketing briefs, generating code. Those are all use cases for generative AI. Classification use cases. An email comes into customer care. We want to classify it as a problem, as a question, as a new product idea. Because why do we want to do that? That helps us automate the workflow. Finally, we have content extraction use cases, when we can take a large corpus of text, extract the top ideas, summarize it, maybe even get some structured information out of it so we can use it down the line. And then, of course, we have a set of a lot of utility use cases. For example, checking grammar in your latest blog post. So what I will do next is play through a few demonstrations of these use cases. I think it's always a good idea to understand what we're trying to build. So this is an example of conversational AI. You can also say maybe it's intelligent chatbot. We're asking a large language model a question. It's responding with some answers. Another variation of this is chat with documents, where we can upload a document into our application and ask very specific questions that are only known to this application because we gave it a reference document. So this example is again conversational AI, and the next example is also conversational AI, but in this case it's shown as a traditional chatbot interface. So let's let this one play through. So of course, if you've ever interacted with a chatbot, you know what that experience looks like. We click on a little icon, and what's different about this particular chatbot is we're also chatting with a very long document, 500-page document. We don't want to read it all. We just want for specific questions about this financial report to be answered. So through a particular implementation of a pattern, we'll talk about that pattern shortly, we are able to upload the document, immediately start asking very technical questions, and get the response. So conversational AI, I think we understand this one pretty well. Let's move on to the next use case. And there are actually quite a few different things that you will see in this demonstration. I'm not trying to impress you with the user interface here. You can see it's mocked up, but I think you'll get the idea. So the scenario here is we have a virtual agent that has been chatting with a customer. We want to turn it over to a human agent. And so we want generative AI to help us out, to understand what has happened so far. We've done a few things here. We have created summary. We have done a classification on a topic of this conversation. We have determined sentiment, and finally, we did entity extraction. Okay, so generative AI helped us achieve a lot of tasks. Now, this use case is even more interesting. Let me pause it for a second so that I can explain it. I wanted to pause here because to me, this really shows how sophisticated we can get with the implementation of generative AI. The use case here is that we have two sets of contracts. This is commercial agreement, a legal document. We have one document that's provided by us. Let's say IBM and a third-party company need to agree on a contract. So we have a reference document, we have a document that's sent to us by third party. Generative AI and large language models can compare those two documents and tell us that they match. Right, so I'm going to let it play through, but let's just think about it for a second. In general, when we talk about computer systems and software implementations, it's not difficult for computer systems to compare numbers. However, it's extremely difficult to compare unstructured text. But large language models, because of the way that they're implemented, they're able to do that. So in the first example of the document, it compared them. It looks good. In addition to that, it told us that we have some PII information, personally protected information, so we should probably remove it before we store that document. Here's our second document. And when it compared it, look at everything that our generative AI application identified. So we have a lot of things that are missing in the contract. Not only did that, but it also told us the actions that we can take to fix it. So why did I show you these use cases? To show you the potential of what we're trying to build. Now let's think about what you have seen in my demonstration. I don't know if you've noticed that, but every example that I showed you was working with unstructured data as input. So as you're thinking about the generative AI use case, you're not going to be working with databases. You will be working with documents, with website data, with email information, with unstructured data. You can produce output as structured data, as you have seen with the entity extraction use case, but a lot of cases it will be unstructured too. Now, you may be thinking at this point of time, well, wait a minute, I saw this amazing demonstration of an application where I could just type in, where I could point my application to a database that has structured data. Let's say it's a sales database, and I said, can you tell me why my sales are down, or why did my European team did better this year than North America? And all of a sudden, you get an explanation back and you get a graph back. It looks amazing. It looks too simple. What I'm here to tell you is that demo that you saw, is it using generative AI under the covers? Absolutely. Is it using large language models? Absolutely. But it's not that simple. It also has a lot of other components. It probably has business rules, orchestration, business logic. And most likely what they're doing is they're using large language models to generate SQL, which is then translated to query the structured data. And then the last bit here about our engine, about the large language models that I want to mention is what's called the multimodal models. So these are the foundation models that can be used to translate text to image or audio or video. And at this point of time, again, if you're working on implementation today, I would consider it emerging use cases. If you are creative or marketing professionals, for you it's not emerging. You're probably using websites like Midjourney. You might be using Adobe tools to create this, but if you're working in financial industry, in retail, in public, in federal, in industry for predictive, it's still new, and all of us still have a lot to learn. Now, the last thing I want to mention about the model here, I do like to use text-to-image models, and so I did work with one of the fun models here to create, I gave it a prompt to create a picture of a chief snack officer, which is what it came up with here. So as fun as it is to work with these fun text-to-image use cases, what I'm going to focus on for the rest of my presentation is large language models and the types of things that we can implement with them. Of course, you have heard a lot about retrieval augmented generation, and I think by this point of time, it's a recap, it's a summary for all of you. As great as large language models are, they have a limitation. They are frozen in time, and they only have the knowledge that they were trained on. Well, what's the problem with that implementation? We want to use these large language models to interact with our company data, which these models were not trained on. And for that, we use a pattern called retrieval augmented generation. We attach a knowledge base to our implementation, and we look up information in that knowledge base before we ask our large language model to perform a task. From the implementation perspective, this is exactly where MongoDB, specifically MongoDB Atlas, comes in, because we will be using it as a knowledge base, as a vector database for our generative AI implementations of the RAG pattern. We will do a little bit deeper deep dive into this later, but there is just one more thing that I want to share with you regarding the use cases. I think that most of us here are probably software engineers or data scientists or AI engineers. And when I introduced things like classification or entity extraction to you, I'm sure it immediately made sense. But in order for us to get started on our projects, we need line of business. We need our business stakeholders to approve our project. And so what we need to do is we need to speak their language. And what I have shown you here is just a few examples of how we can map a business use case into a specific capability of a large language model. So most of the use cases that you see here, not most of them, all of them, we have implemented. A lot of them have to do with customer care, and as you have guessed, they're implemented using conversational AI as well as the RAG use case. We have done a lot with the financial services industry. They are very interested in summarization, right? They don't have time to read the annual reports and all the financial documents. They're also very interested in classification and sentiment of things like news headlines, which CIO or CEO was mentioned in a news article, because that type of information can have a big impact on performance of their investment funds. So a few more use cases just to give you an example. And the main reason why I wanted to explain this to you is because when you are discussing with your line of business, is generative AI the right implementation for this use case, you have to be able to do this mapping of a business use case to the capability that you're going to use. Okay, so we have defined our use case, and the next thing that we need is to make sure that we have the right tools and the platform. All AI-driven applications have multiple layers, and they will have at least 3 layers. We have the user interface layer, we have the business logic layer, and we have the data layer. So from the IBM perspective, when we decided to build our AI platform, we wanted to focus on the business logic layer. This business logic layer includes large language models, machine learning models, business rules, and orchestration code. You will need all of those components to build applications. From the data perspective, and data is used both as persistent layer as well as the knowledge base for RAG use cases, you can use MongoDB as well as many databases that you may have in your data lake house. And then finally, for the user interface layer, what we have learned from working in our customers is a lot of them have existing applications. If they want to create Streamlit applications, Flask applications, Node.js, JavaScript applications, they can do that, but a lot of them love the UI that they have today. They don't want to reinvent it, so we don't want to reinvent it with them either. We provide a standard interface to integrate with our business logic. So everything that I'm showing you here today, we're focusing on this business logic implementation, and the user interface is primarily there for the example. So at this point of time, what I will demonstrate is how we can build the simplest application in our platform, Watson X AI. So let's take a look at what we're building. It's a very simple chatbot. So it has just a place to ask a question, and when I typed in my question, we want to answer it. It makes a REST call to my service that's hosting the large language model or my application. I get the answer back. And again, it's a really simple building block, but let's take a look at how we will build it. So I log into Watson X AI, my AI platform for AI-driven application development. And in the prompt lab is where I interact with various large language models that are included in the platform. From the IBM perspective, our philosophy is that we want to include the best of open source as well as IBM curated models. So this is what you're seeing in this list. And for this particular use case, I will select one of Meta's models, one of the llamas, and next I will change some of the parameters. So I'm asking the model to produce output in a certain format. And I also want to tell it, please don't stop mid-sentence, so I have a stop sequence. Now I'm testing that to make sure that it can answer my question. And since I'm happy with the result, the last thing that I need to do as an AI engineer is integrate it with my user interface. Okay, so right here in the product, I have a place where the code for integration was generated for me. So I copy that code and I paste it into my client application. Okay, so what you see here is just a simple Python client application, and I changed formatting a little bit, but I can tell you I didn't change anything that was generated. So I know it was a super simple example and it was recorded, but I did it mostly so that I don't have to waste your time here. But what I wanted to show you here, that 2-3 minutes, I can build that simple block, right? I can build a simple building block of my application. And why was it important to build it quickly? Because even in the simplest application that I build, I will have to do this step that I showed you, the prompting, the integration. We have to do it over and over and over again. I showed you an example of what looked extremely simple from the user interface, the transition from the virtual agent to the real one. That was at least for interactions. And so therefore, we need to be able to do things quickly, we need to be able to test them quickly and deploy them quickly. So that's definitely one of the main things that we're focusing in the platform. Let's take a look at one more examples. Hang in there, guys. 10 minutes before the reception. We're almost there. So this example right here is an implementation of the RAG use case. I think also by now you know what it looks like. And you can tell it's RAG by user interface because in addition to the answer, you will always get these sources. Where are these sources coming from? They're coming from the knowledge database, which in our case is MongoDB. Okay? So from the implementation perspective, I just want to walk you through the steps of what it takes. So we take data that comes in many different formats. It could be PDF, it could be emails, Word documents, website, and we load them into vector database. So this is MongoDB Atlas. During this loading process, the words are not stored as string. They're not stored as blob. They're converted into what's called a vector, a sequence of numbers. Why does that happen? Because computers speak numbers. They don't speak Spanish. So that's why we need to go through this conversion. This is why we need a specialized database. And after we do that, we're able to do what's called semantic search, which is meaning-based search, retrieve the information, and we integrate it with our large language model. So we have done our use cases, our implementation really quickly. The last thing I want to show you is show you why governance of AI applications should not be an afterthought. And we'll do that through a couple of demonstrations. So let's take this one. So I don't think I mentioned that I live in Minnesota. And if you have known anybody from the Midwest, you know that once in a while when you talk to them, they like to say, what? You betcha. So let's say you hired a new programmer, a new AI engineer, and he thought it would be hilarious if your chatbot answered every question with you betcha. Okay, it started with that. And so very harmless type of joke. And so he pushed it into production. And now we're interacting with our chatbot. And there you go. Now everything is coming back with you betcha. Again, this is harmless example, but you can see this could get a lot worse. So what I wanted to explain to you how we can prevent that using the capabilities in our Watson X platform. So we're doing the same thing in the beginning here. We are creating our prompt, but instead of hard coding all the information into our prompt, we're going to create a parameter, okay? And by creating a parameter, we are limiting the information that can get injected into the prompt. Okay, so let me just skip through to a little bit more interesting part. So I save my prompt. And in addition to saving the prompt, then we go through the documentation step where we're asking our developers to start tracking the instructions that we're sending to the model. And what this tells me, what I highlighted here, is it said as soon as you start tracking your prompt, nobody can change it, right? Which is exactly what we want here. We don't want people just injecting random instructions into this. So we have, if we scroll down about what we documented, I have my model documented, I have my prompt, I know that it should only accept the question as my parameter and nothing else. And then we go through the deployment process of this prompt. And as soon as it's deployed, I get a REST endpoint. Okay, so we have a REST endpoint and that I can now interact with. So from the integration perspective, still really easy to do, still standards based. But if we take a look at my code that it would take to do this, no more hard coding the prompt so that a junior programmer can basically do whatever they want, right? We're making very structured, and that's definitely a part of the governance. So since this has been a pretty long day, I think I'm going to get to my summary pretty quickly. I wanted to make sure that one of your takeaways from here is, I know you've learned a lot about generative AI, and you probably have seen similar capabilities from the prompting, from the integration perspective, but one of the things that we take in IBM very seriously is the governance. And governance, it's not just model monitoring. It's not just my model is doing well, I should update it. It's also about providing transparency about how your prompts are documented. It's understanding where your prompts are in your development cycle. It's also working together with your model risk governance team, because their job is to make sure that lawsuits don't happen. So they want to document everything, they want to be able to easily find everything, and that's one of the main things that we focus on. So I want to show you just one more closing slide here to explain how we view our platform and what we focus on as we deliver the platform for building AI-driven applications. Number one is supporting open source is key to us. So any large language model, the most popular large language models, you will find them readily available on the platform. The second thing is we also support bring your own model. So if you found something that you like that's not a part of our platform, you can bring it in. Number two, targeted. In IBM, we also have a lot of experience building large language models. We know how to build them with trusted data and for specific business use cases. So we're also going to provide our own large language models. Trusted, we already talked about importance of governance. And then the final option here is empowering. What we mean by that is the Watson X platform is one of the few hybrid cloud platforms. So if you choose to run it on IBM Cloud, you can do that. At the same time, you can take it over to any one of the hyperscalers as well as on premises. So I hope that this presentation gave you a few ideas, a few tips on how to work on your AI-driven project implementations. Thank you very much, and we're still 2 minutes early. We can get in line for those drinks.
Thank you so much, Elena. Let's all give it up one more round of applause. If anybody has any questions, do we want to do a live Q&A now, or do we want people to find you later? You want to do Q&A now? Okay, great. If you're not rushing away to go get drinks and you have a question, please raise your hand and I'll come bring the microphone to you. Okay. Okay,
Yeah,
great.
thank you.
Seems like we don't have any questions. If anything comes up later, feel free to find Elena. Okay, great. Thank you all so much.